Continuing on our merry way, we got a little distracted there. So let's look at the same thing here. This one is slightly different because the leading coefficient is a 2. So it kind of throws off our whole ability to break this box up cleanly. So what I like to do is say 2 times negative 15. That'll give us sort of an idea of what these two terms would have been right here. Gives us negative 30. 2 times negative 15 is negative 30, and then I'm going to do the same thing. I'm going to look for two numbers that multiply together to make this versus just the C here, but add together to make positive 1. Well, I know that 6 times negative 5 do exactly that. They multiply together to make negative 30, but they add together to make negative 1. So I'm going to put my piece, review what my pieces would be. 2x squared, this is really simplified down from 6x minus 5x minus 15. I'm going to put those in my box and factor it out to figure out what my length times width would have been. 2x squared plus 6x minus 5x minus 15. Okay, well, I'm going to pull this direction first. It doesn't really matter which term you pull out first. From there, it's just a puzzle. So what do these have in common? 2x. So this must have been x to create that. 2x times 3 is 6x. And then x times negative 5 must be negative 5x. So the picture is not our answer. The answer is actually what is it in terms of the components here? Well, it's x plus 3 times 2x minus 5. I'm going to do another one here. It's a little bit different. It has a 2x cubed, 20x squared, 18x. Well, that doesn't look like a quadratic, but I have 18, 20, and 2, so they all have a leading coefficient that is even, and then a cube and a square and an x. So I can actually factor that x out to make my life a lot easier. So 2x times what is 2x cubed? It's just x squared. Plus this term right here, 2x times what is 20x squared, 10x, and then 2x times what is 18x, 9. Okay, now I'm going to treat this more simply because I simply have that leading coefficient of 1 in this, so I can look. I'm always really saying 1 times 9 or 2 times 15, or back here in this one it was just that 1 times 12. We just ignore it because when you multiply the 1 times 12, it doesn't have an effect. So 9 must be 9 and 1 to add together to give us that 10. So I'm going to refactor that out, make a quick little sketch for myself. 1x squared plus 9x plus 1x plus 9. And then we're just going to ignore this guy for right now. So x, 9, 1. So 2x times x plus 9 times x plus 1. All right, okay, let's look at some tricky problems here. I have 4x plus 2 to the x plus 4, 4x plus 2 to the 4th, and 2x plus 7. Okay, well, when I look at this, one of the things you might notice is that you have a 4x plus 2 and a 4x plus 2 in each of your terms here. So I can rewrite this whole thing right here as 4x plus 2 to the 4th times 4x plus 2 to the x. And we reviewed in the past that if I have the bases being similar, I just add the exponents. So I'm undoing that there. I'm taking it apart so that I can do some clean factoring later. So the 4th, 2x plus 7. Now, when I look at this, I have a 4x to the 4th. I'm sorry, 4x plus 2 to the 4th. And then I have another 4x plus 2 to the 4th. which allows me to say that I have a common term here. It just happens that that term is a binomial, like a group. And then I have my b and c or whatever. So I have like a times b and a times c. So I'm going to pull that a out. So 4x plus 2 to the fourth times the quantity 4x plus 2 to the x plus, I factored this guy out here also, so I almost have like maybe a bracket would be easier to see there, plus 2x plus 7, like that. And then there's not any further you can go there, it doesn't get any cleaner. That is as clean as it gets. Okay, so I'm going to show you a little trick here on this one. I've got x to the fourth, x to the second, and no x on this one. So it looks in a way like a quadratic, except I have a 4 and a 2 instead of a 2 and a 1. So my trick is going to be, we've seen this before, let x squared represent x or something like that. You could let it be y if that is easier for you. So we can rewrite this whole thing here as 12y squared plus 5y minus 2. Then I'm going to factor this. So I'm going to multiply those two terms together. Negative 24. Two terms multiply to make negative 24, but add to make 5. 8 and negative 3. If you feel comfortable with your tables, that should come pretty quickly. So I'm going to put this in the box to allow me to factor it. 12y squared, 8y minus 3y minus 2. So 4y this way, 3y this way, plus 2 minus 1. So our terms are 3y plus 2 times 4y minus 1. But remember, our original problem didn't start with a y, it started with this x, right? But we said x squared is the same as y. We kind of use this little trick. So every time I see a y, I'm going to go back and replace it now with that x. So I'm going to rewrite this as 3y x squared plus 2 times 4y, change it, x squared minus 1. So we're going to practice some more tips and tricks here in a minute.